The other component of the paver system is the edge restraint. And typically you're going to see in most commercial applications concrete curbs and edges. You see some typical concrete curb here. This is what we're trying to avoid with paver construction. Paver systems are very durable. Again, the paver is 8,000 psi. You're not going to break it. You can unweave it, so to speak. You can with braking and turning if the edge restraint is not there, or if it's not laid in a pattern that's appropriate, or the paver doesn't have the appropriate aspect ratio, you can disturb it. And this is what we're trying to avoid. This application here used a landscape edge, in an inappropriate way. That's fine for keeping beauty bark confined, but it's not good for confining a parking stall. And so you see in this application that line's a little bit wavy. There is no edge there, and that's what we're trying to avoid. We have requirements for edging materials. Typically in most commercial applications, since there's a lot of municipal applications here, you'll always be typically a precast or a poured-in-place concrete curb, maybe even a cut stone type curb, but you're going to see a concrete curb in most applications. I've got some slides for some pedestrian and residential applications using a dense graded base and a plastic edge. That's compact base at the edges. The reason we can't use the open graded base is the spikes won't stay in that. For a plastic spiked edge, you typically see with even industrial dense graded aggregate paver applications, you can spike those. There's a very heavy duty industrial plastic edge that's used a lot, but it won't work in pervious applications because the open graded aggregate just doesn't have enough fines to grip the spike. So we have a detail for that, and then in pedestrian applications you can also do a geogrid wrap. Curbing, I think we've seen enough applications of curbing to know it can be either a pronounced curb like a typical gutter, or a recessed or flat curb. What we're trying to do, and you can see here in these, the upper two photos are kind of what not to do. Asphalt, unfortunately, does not make a good edge. There's just not enough structure there at the edge. Even thickened asphalt, you'd want to use a concrete curb, a recessed concrete curb there. And you see the detail on the bottom on the left-hand side. Great application where they actually, instead of saving to cut some pavers around that typical radius there at that planting area, they're using concrete there, and that's a good application of using the right material, the right place. And of course, concrete slabs or parking lots with a thickened edge can be used, as on the lower right-hand side. Curb and gutter is fine as well too for municipal applications. Here's an application in Portland, in a project that was done in the city of Portland. A combined sewer overflow problem in the Westmoreland district. Great application of a concrete curb separating the asphalt from the permeable interlocking concrete paver. A lot of aesthetic requirements. Sometimes you'll see the architect or designer will want to have the paver be solid, no curb express. So we can recess the curb, mortar or adhere with adhesives, high strength adhesives, as you see in the lower left-hand corner there, and still be able to give that same effect. So there's ways of doing it. You just need to make sure you're structurally okay, and then figure out the method that will meet your aesthetic requirements. For edge restraint guidelines in pedestrian and residential, there's a couple of slides here that kind of explain a lot of the installation or contracting side of this. They're important to the show because this is how they would have to be installed, to put in a dense graded base with a staked plastic edge at the side of the installation. So how we would do that is typically you'd excavate, you'd put in the compacted dense graded base on the edges. You see that labeled here on the slide, going in backfill with the open graded. In a section or a detail, this is how that would be done. The open graded material in the center here, dense graded for 18 inches on the sides and compacted that way. You may want to use some geotextile to separate the two if there's a lot of fines in there, but not necessarily for the base or for the bottom of that. And then the construction is similar to the rest of the permeable interlocking concrete pavement system. Compaction, checking and setting the grades. You've got to be very careful. You have two bases here, so you're going to be setting grades at two different areas. This is one of the downsides of this. You can get some spillage or leakage onto that. You need to be aware if you've got enough area to cover for that if that happens. If not, you'll have to have that taken out and done remedially. Then setting the pavers. Pavers are typically aligned and then compacted, and aggregate is swept in to the joints, and that's how the plastic edge over that dense graded base is done. So in a residential application, you don't need to pour concrete. You can actually do a staked edging. You just have to use a typical dense graded road base instead of the open graded base. Sweeping is then done to sweep the aggregate into the joints, and the joints are filled here. The other system for pedestrian-only application, obviously you can use concrete or this dense graded base option, but we can also use a geogrid wrap. And basically there what we're doing is providing a geogrid, kind of an extra, not geotextile, but geogrid that will be in the base, the bedding layer of the paver, and kind of hold that edge in place. So you basically extends about 3 feet underneath the bedding layer of the paver. It's then wrapped and goes over into underneath the bedding layer there, and the pavers are set on top. And that can be suitable for light-duty residential applications as well, if you're worried about having the two different bases. The other thing that's done commonly here is a troweled concrete edge. We don't have a lot of soil problems. If you had heaving soils or clays or problems like that, I wouldn't recommend this, but we do see a lot of troweled edges in light-duty pedestrian or residential applications. Some discussion earlier about geotextiles. When do we use geotextiles or not? Here's some guidance. If you download these slides, you can get the suggestions here. There is a AASHTO bulletin, the AASHTO M288, that's in the ICPI design manual. Referenced in there talks about specific selection when you do want to consider that, or if you do. I'm with Chris and the others that have been mentioned. I don't think you want to unless there's some reason, but the industry guidelines typically tell you to overlap geotextiles. If you do use them in the bed, overlap them 12 inches. In real fine-grained soils, use 24 inches in overlap. This here is a little bit more than a 24-inch overlap. Typically, it's cheaper to just use another roll than to cut. so it all depends, but there is a lot of waste going on there. Pre-installation, basically, how is the material going to be staged for use, and where is it going to be staged, and getting access for a haul lane or those types of things. We want to keep all equipment off of this system as much as we can. No different than pervious concrete or porous asphalt pavers are the same thing. We want to keep dirty tires, construction equipment off of that. You can see in the sequencing here, even though this is a back dumping slide explaining that, you can see the problem with construction trucks compacting underneath those wheels, trying and getting that material there, whether that was from grading or not, I don't know, but the slide in the lower left is this process of back dumping where we're pushing the aggregate ahead of and using clean tires and ways to keep the dirt and the fines off of there. Another slide with some bad examples, the geotextile. You can use geotextile on the site. It makes a great cover for putting underneath aggregates. Permeable aggregates are more expensive. Open graded aggregates, washed aggregates are typically more expensive than regular dense graded road base. So your contractor is not going to want to have a pile of that and not use every bit of that that's available on the site. Consequently, when he goes to pick it up with his bobcat or backhoe or whatever he's using to dump the material, he's going to get down as low as he can with that bucket. If you've got a geotextile laid out there on the site, that will help keep those aggregates separate and keep any fines from the material below from getting into that. So pay attention to that. Use, as you see in the lower right, good housekeeping processes here. Pavers have the unique thing to be able to be installed by hand in smaller applications or in large applications. It's not always the size of the application that matters, but generally larger applications are more affordably done with mechanical installation. It's a very interesting process. It's basically a clamp, a specialized equipment we have in the Puget Sound area and all along up the I-5 corridor between here and Portland. I think we have about 6 contractors now that have paver installation machinery, and that really saves time, especially on prevailing wage projects. But you need to make sure there's site access and that available. Basically, the material it's a little forklift, very light, you can run it on the pavers before their aggregates placed, and it clamps onto a layer, about 10 to 12 square feet of pavers at a time. And then that's mechanically driven over to where it goes and it's dropped in. The main thing about the mechanical installation is you have to have a paver that the bond is set up as it's being manufactured the way it's going to be installed. So you want to check with your manufacturer to make sure that what materials they have that are available for mechanical installation application. Mechanical installation saves phenomenally on the amount, especially as, pavers themselves don't cost as much as the labor typically sometimes to put them in. So if we can reduce that labor through mechanical means, we can save. And 1,000 square foot per man per day that's going to be at the top end of manual paver installations. Typically it's about half of that. But we see mechanical installations go anywhere from 3,000 to 10,000 square feet per day per machine. We can lay them very fast. We can lay them in inclement weather. As long as the aggregate and gradations of materials are unfrozen, they're not frozen, we can lay them. And the nice thing about pavers is they're already cured in the plant. So you don't have to wait any time. So, these are things that you'd want to consider when you're evaluating one material or the other. Each material has its features and benefits to use. All right, we'll go through real quickly here the installation of the base and sub-base materials. Here's that gradation comparison between the sub-base, the number 2, the bigger material on the left, and the number 57 on the right. You see, as that material kind of lines up, you're going to get the 57 chokes into the number 2 and the number 8 chokes into the number 57. So those gradations tend to overlap. And the materials are passing around here for you to see. There's the kind of a schematic picture of those different materials. Notice the angularity of the face, the crushed rock. You can tell if it's 90 or 95% crushed surfaces. If the number 2 or number 57 is not available at your local quarry, it doesn't mean you can't use permeable systems. This is in the ICPI manual. I think it actually comes from Ferguson's book, and that's the way of determining your layer choke criteria to make sure that one aggregate's gradation doesn't fall into the next aggregate. You look at the D15 or the D15 is where the diameter of the aggregate is the particle size of which 15% of the aggregate is finer. And you get that off the gradation report. And you can do a D15 to D50 analysis and determine if that stone will choke. And then there's another formula to use for permeability. You check those 2 criteria and you can probably very easily find a stone at your local quarry, as long as it has 3 conditions, right? It's crushed, angular, washed, and durable. Okay, no fines and durable. Okay, the compaction is just like, and we've been through this, basically in pavers and with some of these aggregates, you look at in the base courses, you're not going to get a nuclear test done on an open graded aggregate. You're not going to find anything. There's ways of doing in what they call the backscatter mode, but basically it's a prescriptive path. You typically would want to go out and have so many passes with the 10-ton roller or so many passes with a 13,000 foot-pound compactor. These are not light-duty compactors. These are heavy-duty equipment and materials, and some of the newer ones actually have little compaction gauges on them. I used to always tell when I was doing a paver installation if my compactor, a smaller one, was going over compacting the area, if it started bouncing, I usually knew I was dense enough. Okay, so there's prescriptive things where a good contractor that's attended certification courses. ICPI also does have a certification course for permeable as well as all paver installations. So, and there's specifications, guide specifications that tell you how to use that spec in your spec to make sure you get someone that's trained and qualified. Screeding of the materials, very similar to screeding concrete, except this is a stationary rolled system, and that's how you install the bedding and the bedding layer material. Again, to review, the ASTM number 8 stone chokes into the 57. You can use smaller aggregate in the joints. Similar gradations are certainly acceptable. And look at your joint size to determine what the joining material, if you have available locally, is suitable. And here's that chart again. We showed this before. Keep the bedding material clean. Use it in, it's only 2 inches layer, so it doesn't need pre-compaction. But you'll use screed rails to do that and set it on a pre-graded, and there are requirements in the guide specification, which we would get into an advanced course of what those variations are allowed. But we're also seeing a lot of laser-guided equipment where they'll set up a laser transit and just be able to, it will adjust the bucket to a certain depth. That makes parking lot installations a lot easier. But in smaller commercial applications, we'll see hand screeds. Larger ones, the larger you get, you'll see different types of screeding equipment to screed that base layer or that bedding layer. You go back in and infill. This guy's touching up with a rake, the bedding layer. Fill where you pull out the rail, fill that back up with bedding material. You can use powered screeding for larger more linear applications. And here's using an asphalt spreader to spread that bedding layer. It doesn't usually take 5 guys to do that. This was the guy's new equipment, and he invited everybody out to take a ride on his asphalt machine, but very economical way of screeding that layer of base. Then the pavers are installed, aligned, as we looked at in the other slide. Edge pavers are cut. Layout will help you avoid cutting edge pavers, just so you know. If you lay out to full and half pavers, you can avoid having to do a lot of cutting. And you compact typically before. Once that aggregate gets into those pavers, once it's swept in, pavers don't move, guys. They are very secure. And if you ever try and pull up a paver in an interlocking application, it's very difficult. And then a final compaction of that material. Now you want to sweep the material off first, and you always want to keep a guy with a broom there, especially in permeable application, to keep any fines and sediment from hitting the permeable surface. Design basic, 3 ways of looking at permeable designs. For pavers, they're in the manual. Full exfiltration, we used to say that was where we had pretty sandy soil with infiltration over 0.5 inches. I think the LID manual changes that to 0.3, if I'm not mistaken. So, and we're seeing improvement based on some of the work that Curtis is doing and others, that we can get good drainage and good infiltration from systems that are even less than that. But the LID manual allows for down to 0.3 inches per hour. You use full exfiltration, no subsurface overflows or overflow pipes, but in areas where you do have clay or you'll have another system that you'll want to use for treatment, you can use those subsurface flows and use what we call a partial exfiltration. And then in areas where you have high bedrock or groundwater, or you do not want infiltration in the system, you use a liner and put a no exfiltration system in. One thing that is unique to pavers, I haven't seen this in other materials, but it could be used in other materials, as well as this idea of an observation well. So at the low end of your pavement, you can install 1 or more of these. It's basically just a 6-inch diameter perforated pipe that goes down, as you see in the section here on the lower left hand, down to your native material, and then it's capped. You can put it in a little utility structure so you can get access to it. You can sample from it. You can open it and see during a rain event if you're getting infiltration or if you're filling up the system. It kind of gives you an idea where water is in your system. So a very handy way to monitor and see if your system's functioning. Talked about maintenance, and it really is a function, and I would recommend attending the O&M operations and maintenance class if you haven't already. You want to make, a tree-lined street is going to require more maintenance than an open parking lot, okay? As engineers and designers, we need to be aware of that. We just need to make sure that we probably tailor our maintenance to what we need, if we have run-on like this on the on the lower right-hand side, or if we have had an incident during construction where we've had a spill or something onto that, we maybe want to do maintenance a little bit differently, but tailor it to your job and your specific job. Now, I don't expect you to be able to read this, but there is a chart in the ICPI design manual about balancing the structure and hydraulics capacity of these systems. So this is a chart that talks about the structural loads. Basically, it's designed very similar in an asphalt section. Number of easels, more easels you have, the thicker the base will be for structural performance as well. Typically, what I've seen in our area, hydrology governs. I'm not sure that's always the case, but usually you design for the hydraulics first. You go back and check it and see if it'll perform structurally. It usually does. But there is a chart there to be able to tell you that.